Last step left to take in order to have implemented the RSA encryption scheme from scratch is the calculation of the private key. RSA defines the private key to be the number d, where the number d is the multiplicative inverse of the exponent when calculated modulo the product p-1 times q-1. Now it's time to remember the extended Euclidean algorithm that can calculate u and v such that u times e plus v times p-1 times q-1 is the greatest common divisor of e and the product p-1 times q-1, which is 1, as e was chosen as a value with exactly this property. From this, it's then clear that u times e is 1 as well, as v times p-1 times q-1 is a multiple of p-1 times q-1, and from this it follows that the private key that needs to be the multiplicative inverse of the exponent e really is just the value u as calculated by the extended Euclidean algorithm. Now, the extended Euclidean algorithm calculates for a and b two values x and y such that x times a plus y times b is the greatest common divisor between a and b. If b is 0, the greatest common divisor is a, meaning x is 1 and y is 0, which can immediately be returned. If b is not 0, and at this point it can be assumed that a is larger or equal to b, then the greatest common divisor between a and b is the greatest common divisor between b and the remainder of a when divided by b, which is a modulo b. Triggering the extended Euclidean algorithm on b and a modulo b gives u and v that can be used to calculate the desired x and y to calculate the greatest common divisor of a and b as a linear combination of a and b by reshuffling the terms involved. Having arrived at the final values of x and y, these could be returned in order to complete the implementation of the extended Euclidean algorithm, and with it, complete the implementation of the calculation of the private RSA key. Going back to the driver of this RSA implementation and running the example on the plaintext, then successfully managed to encrypt the plaintext with the RSA public key into a ciphertext that could then be successfully decrypted with the RSA private key back into the original plaintext. This then concluded the from-scratch implementation of the RSA encryption scheme.